I'm going to explain about my research that is about comparative study on segmentation approach blood image for iris recognition. My supervisor is Dr. Shamrin Bilasmuni. On the chapter 1, I'm going to explain about what is iris recognition, what is all about. So it's basically an automated biometric identification method used to mathematically pattern recognition techniques on images of both iris and individual eyes. Okay, why we consider is important because this is unique biometric traits and stability over time and high matching speed. The program background is, despite the advantage, iris recognition faces significant challenges, particularly from motion blur image. This phenomenon often occurs in uncontrolled environments, severely decreases image quality. So, motion blur leads to inaccurate iris segmentation, directly impacting a reliability of this recognition system and resulting in misidentification or reject authentications. Now, my research aim is to compare efficiency various segmentation approach for motion blurred iris image in iris recognition system. First is the objective R3, that is to review and analyze segmentation algorithm for the iris recognition. Second is to conduct comparative evaluation of various segmentation algorithm for motion blur image datasets and particularly include deep learning-based approach, multi-resolution feature, and GANs. To identify effective segmentation algorithm for motion blur images. My scope is research we implement UBID version to benchmark datasets and appropriate method pre-processing, feature extraction, normalization, matching will be identified during extensive literature review. My core objective is review current algorithms and comparative analysis of method and perform evaluating UBIDS version 2. Let's go into chapter 2, literature review. From the literature review, we can currently highlight a significant shift in iris recognition. Early approach such as this employment, Kenny H detector combined with circular Hawk transform laid foundation groundwork of the struggle with the image degradation. More recent advantages, particularly in deep learning, have introduced models like CNNs and GANs, including SPEC deblur gun. The models demonstrate markedly higher robust handling and conditions such as motion blur and noise. This is my case studies from the various researchers I gathered. So Document is famous for Gabor, familiar work in iris recognition fundamental for secure systems. For the chapter C methodology, flow of research framework. This is my flow of the research framework, starting with literature and research methodology, and then I have segmentation, pre-processing, normalization, feature extraction, matching, and then number third is result analysis and development. Methodology framework algorithm dataset. There are algorithm and conduct is both classical process image technique and advanced machine learning models. Comparative analysis is about circular Hawk transform, local binary, and then GANs. CNN and GNs perform evaluation is about the motion blur image source from UBI's dataset, accessories metric as segmentation and accuracy and robustness. The UBRS version 2 is methodically created by Universal of Barra Interiors such as Curie resources for the study. This version is designed for simulate high realistic and challenging image accuracy condition and process significant level motion blur and revise the notion profiles. For the chapter 4 is research design and implementation. For addressing motion blur in iris segmentation, we are facing real-world challenges such as motion blur, common image artifacts, significant decrease image quality and clarify. For segmentation limited is traditional segmentation effect on clear image demonstrate mark and perform when faded is motion blur data. What the comparative analysis need is to validate the most efficiently significant methods for blur iris image. For the experimental environment system setup, I use software and libraries is Python programming language, Visual Studio Code, OpenCV image, and then NumPy for numerical operation, TensorFlow and Keras to deep learning. For the hardware specification, I use Intel Core i5 processor, 16 GB RAM, and optional NVIDIA GPU for accelerated computation. UBRS version 2 data details. I use 88 district eye samples for 44 individuals. Challenge conditions capture under noisy and non-cooperative scenarios. Key obstacle motion blur, eyelash occultation, and specular reflections. Pre-processing and feature extraction. Um, for first step is iris normalization. We rubber sheet model for the consistent eye representation, standardized dimensions, and for feature extraction, we use utilizing 1D log cardboard filters, detailed structure and patterns. For template size, we generating 9600 gigabytes iris template. This is the output for CHT, and this is for the templates normalized for distance for 8 meters. For iris matching, for iris matching accuracy, matching algorithm I use Euclidean distance for similarity comparison. So inner eye similarities 98.90 accuracy, inner eye similarities 95.30% accuracy. Performance reflected by occlusion with the eyes. So highlight is GA and exhibit method demonstrate high resilience. For the chapter 5, For the chapter 5, iris recognition through local binary patterns, feature extraction, a performed phenomenon through blurred image. Research summary, objective and key step. Research of LBP is iris recognition, particularly under motion blur and UPRS version 2 data set. The methodology involves three critical steps: pre-processing, feature extraction, and recognition. For recognition, I use histogram matching was employed to compare the identity and iris patterns. For strengths of LBP is robustness, interpretability, and efficiency. For robustness, LBP is the most strong, resilient for moderate motion blur, efficiency handling turns up to 10 pixels. And efficiency is LBP boosts rapid computation speeds, processing image appropriate 12 milliseconds. For interpreting the binary patterns for LGP directly encode local texture features, providing clear and impaired instincts into the iris structure. This is the output for the LBP and comparative. This is the accuracy and robustness. So accuracy is 99.1 is moderate. For robustness is 99.6 is considered high. So LBP offers balance between processing speed and recognition accuracy, particularly scenario, and LBP remain high efficiency alternative. For chapter 6 is research, design and implementation. For leverage CNN address motion blur recognition is key is end-to-end segmentation and feature extraction and blur event feature learning. So dataset I use UPRS version 2, 44 images and 88 samples. For CNN architecture, I use model mobile net version 2, a lightweight and efficient CNN. Mobile weight is designed for mobile embedded version and application to make ideal for scalable biometric system. For the key strengths is blur, robustness, automation, and generalization. So this also have the eye accuracy like 98.90 and 95.30%. So competition trade-off is uh, training hours is 4 hour GPU, 10 minutes CPU. So we consider is GPU required and CPU friendly. For conclusion is for chapter 7 is the conclusion. So comparative summary of the method. So this is the conclusion for all the CHT and Kenny and LBP and CNN. So for the all of this have a high accuracy and speed and hardware needs. For that, we see the strengths and limitations. CNT and Kenny has faster interpreter segmentations, but fail under blur, 15% limits real world development. For LBP, balance, speed, accuracy for texture balance extraction. But structure development degrades significantly with extreme blur or noisy data. CNN is state-of-art accuracy and generalization across the diverse dataset. So computation expensive, requiring significant GPU resources for training and interference. So let's see real world applicability. Embedded system and high security DLC system. So the conclusion is no one size fits all solution. Method selection depends on specific use case requirements. So for every each other, we cannot choose this is the best, this is not the best. Like for the requirement, we can choose which is the best, but we cannot select one only for my research. So every CNN, LBP, and CHT have their own preference and own specifications on. So based on that, we can choose and develop for the future works. Thank you so much.